Hi friends, welcome to Unacademy. Myself Bhavani. Students, Unacademy offers plus courses for Karnataka CET students. Students who want to excel in CET exam, students who are writing CET exam in the year 2021, and if you are planning to score very good marks, students, then Unacademy offers plus courses for such students. Now, when you apply for a plus course, you will be having, different, I can say options. That is, single subscription, you will have unlimited access. Plenty of batches students, you can enroll your name for any one of the batch, but then while joining the batch, kindly make use of this code Bhavani Live. Okay, this is the code you are going to use, Bhavani Live. There are different plans. We have 12 months plan at the rate of 12,375. We also have a 6-month plan at the rate of 10,125. So whichever plan is appropriate for you, whichever batch is convenient, kindly enroll your name by making use of the code Bhavani Live. Students, when you join a plus course, what are the important benefits you are going to get? First of all, both class 11 and class 12 topics that will be done in detail. All the concepts and whatever essential tips and tricks that are essential for scoring marks that will be shared during that classes. A lot of previous year question paper will be solved so that you will come to know the area from where the question has been asked, how the question has been asked, and how repeatedly the question is asked. So all those you will come to know by previous year question. And you will be also given a daily practice paper, full-length mock tests with analysis, quizzes with analysis. Students, when you keep on practicing, you know that until you practice, you will not be firm with the concept. So it will give you a lot of practice papers so that you can practice well. With the analysis, you will come to know your position, you will come to know how much you have studied and whether whatever you have studied, is it enough required. Okay, so these are the different batches. You see you have a champions batch also. So different combinations are also available. So whichever combination is suitable for you, you can join that batch. And also student, we have free practice tests. Kindly enroll your name for this practice test because you need to attempt as many as question possible. Okay, when you enroll your name for the test, what happens is you will be answering it you will come to know the result, you will come to know the position. So it will be very much helpful for your self-analysis. You need not wait for others to tell you the amount of study what you have done is it enough or not. You yourself can decide whether you have completed the topic from the basic. Okay, so try to attempt as many as practice tests before you face the CET exam. And students, kindly remember, if you haven't watched my previous YouTube session, kindly watch them. Okay, kindly watch them, and whenever you like, do not forget to like, share and subscribe these videos. And under Unacademy also, I have done a lot of special classes, student. So in case if you feel that you should be you need some lessons, you need some mock tests, kindly watch those special classes which I have done under Unacademy. So do not forget to watch all my special classes under Unacademy and also the YouTube sessions which I am taking. Remember, a lot of mock tests I have conducted on whether it is organic chemistry or physical chemistry or inorganic chemistry. So be a part of it, students. So we will be today discussing the important questions on Karnataka CET. Now you all know that in whenever we say CET exams, it's not that the same question will be repeated, isn't it? It is not the same question will be repeated, but somewhere certain concepts are touched many times. So we have picked those questions. I hope I'm making it clear. It's not the same question which will be asked once again, but then the concept student will be the same concept. From the same concept you will be asked questions. Okay, so we will have one such question from the chemical bonding. If you see, the question from dipole moment is seem to be appearing every now and then. So it is better you go through this concept of dipole moment thoroughly. For example, you have the question here. Which of the following possess a net dipole moment? Option A, sulfur dioxide. Option B, boron trifluoride. Option C, beryllium chloride. And option D is carbon dioxide. So students usually question on a dipole moment is it has been asked more than once. It has been seen in the question paper. So whenever a question about a dipole moment is asked, how do we solve it? Now if you have the answer, you can give the answer, student. Okay, so you can give the answer. Meanwhile, let us find out which has a net dipole moment. Now how do we find out? Okay, so if you are from class 11, I think student is saying is from class 11th, that is not an issue. Okay, so yeah, so if you are from class 11th also, you can surely look at the YouTube session, because there are so many questions from class 11. And also remember, kindly watch my previous YouTube classes also, where I have done mock tests on certain class 11 topics, Manoj. Okay, so you can make use of it. I have done on first chapter, second chapter, it's like that. Are you getting it? Okay, so whichever chapter is done for you in your classes, you can go through the mock test, you can answer. Okay, so watch those YouTube session also. Anyway, which of the following possess a net dipole moment? Now how do we find out that the given compound has a dipole moment? Students, sometimes you can think of hybridization. For example, SO2. Now we can use the formula for hybridization, isn't it? What is the formula? Half into number of valence electron on sulfur. So how many valence electron on sulfur we have? 6. Plus, is there any monovalent atom? No. Oxygen is divalent. Oxygen forms 2 bonds. It's a divalent. Therefore, there are no monovalent atom. Therefore, 6 by 2, it is 3. Student, if you get the answer as 2, okay, this question is from chemical bonding chapter. If you get the number of hybrid orbital as 2, then the hybridization is sp. If you are getting it as 3, then it should be sp2, because 3 hybrid orbital means it is sp2 hybridization. You can see 1 plus 2, 3 hybrid orbitals. Okay. Now you can see here, sulfur is bonded to oxygen. So you have 3 sp2. So out of which 2 are bonded to oxygen. So 1 electron, 2 electron, 3 electron, 4 electron. only 4 are involved in bonding. There is 2 free, which will remain as a lone pair. You know that the lone pair and the bond pair will repel. So this bond will come closer. Okay. As a result, sulfur dioxide has a angular structure, like an angle. Okay. Somewhere around 119 degree, I can say. It's an angular structure. Now, dipole moment means it is the bond moment due to the difference in the electronegativity. See, this bond is polar. Oxygen is more electronegative. So, the dipole moment will be on this direction. This oxygen is also on this side. That means the dipole moment is on this direction. So, sulfur dioxide has a net dipole moment. If you take the case of boron trifluoride, in boron trifluoride, if you want to know the hybridization, it is a half. Number of valence electrons are 2. Okay. Number of, number of hydrogen, helium, lithium, beryllium, boron. So 1s2, 2s2 and 2p1. So there are 3, isn't it? So here I cannot use this, formula. So wherever it is applicable, we use it, isn't it? So boron trifluoride has, sp2 hybridization. So here the bond moments are towards this direction because fluorine is more electronegative. So if I'm, adding the bond moment, the resultant bond moment is like this. The bond moment of this bond is opposite direction. So here the bond moments are equal and opposite. So they cancel. It's a vector quantity. So if you take these 2 bonds, its bond moment is towards like this. This will be equal and opposite to this one. If you take these 2 bonds, its bond moment is this direction, which is equal and opposite to this one. Therefore, from any direction, the bond moment cancel. So it has a 0 bond moment. Okay. Or the dipole moment is 0. Okay. It's a planar molecule. Beryllium chloride. Beryllium chloride, if you take, half and the number of, valence electron in beryllium is 2. Number of monovalent atoms are 2. So 4 by 2 means 2. Therefore, hybridization is sp. Sp means it is a linear molecule. So the bond moment is towards this side because this is electronegative. This bond moment is toward this side. So the bond moment cancel with each other. This has a 0 dipole moment. Similarly, we know that carbon dioxide is also a linear molecule whose dipole moment cancel with each other. So the only one compound which has a dipole moment is sulfur dioxide. Around 1.61 dipole moment it has. Okay. So one of the question from chemical bonding is from dipole moment side. Similarly, we have usually, if you see the question papers, if you see the question paper, you will have a question on sigma bonds and pi bond. It may be different compounds are given and you have to find out the number of sigma bonds and pi bond. So this is one of the easy question, but then it has been repeated with different compounds. You have to calculate how many sigma bonds are there, how many pi bonds are there. Or by knowing those sigma pi bond, you should be knowing the hybridization and the electronegativity character. So there are few questions which revolve around this concept, and that is sigma and pi bond. Okay. Now naphthalene is given. So you know about naphthalene. What is the structure of naphthalene, student? You can write the answer, student. The moment you know the answer, you can write it in the chat box. So this is actually naphthalene. So the question is how many, sigma bond and how many pi bond. Whenever such question is asked, kindly see to it that first you are finding out pi bond so that you can eliminate some option. So you can see very clearly here 1, 2, 3, 4, 5. That means your answer is only these three. This cannot be. So one answer you have eliminated. Now you can find out the number of sigma bond. We will see the number of sigma bond. You have one here. You have the second one here. You have the third one here. 4 here. 5 here. 6 here. And 7 here. So there are 8 CH sigma bond. Then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 CC sigma bond. So altogether there are 19 sigma bonds. So this compound has 5 sigma bond, 5 pi bond and 19 sigma bond. As I told you earlier, count the number of pi bond, which will be, which is very much helpful, student. You can eliminate sometimes, 2, 3 options because of the pi bond only. Okay. So this is also one of the question which is, from this area the questions are asked. It need not be number of sigma or pi bond. It can be related questions based on sigma and pi bond also. Question number 3. Now question number 3 is seem to be like it is from carboxylic acid chapter. But actually you should be knowing not carboxylic acid for this, the electronic effect. Students, electronic effects is also one of the important area from where the questions are asked. I effect, E effect, I means inductive effect, E is electromeric effect, M or R effect, resonance effect, or maybe hyperconjugation effect. These effect you need to study well, because to express the strength of an acid, to express the strength of a base, to express the stability of carbocation carb anion, or maybe free radical. In all these cases, these effects are must. Therefore, one more important area when you learn is about electronic effects. Kindly watch my YouTube session where I have briefly explained all these effects. So previous YouTube session you can watch where I have given electronic effect. So kindly watch them. You will get a very good basement for these electronic effect. Anyway, propanoic acid undergoes HVZ reaction to give chloropropanoic acid. The product obtained is, see, we don't have to do anything with the reaction because the product is also given. Now the product obtained is, they have asked about its acidic character. Now what is the product formed here? You see here the product formed is propanoic acid. We have taken propanoic acid. So here CH3, CH2, it is COH, right? Subjected to reaction with chlorination, and it is 2-chloropropanoic acid is formed. This is what this and all we need not know because they have given chloropropanoic acid is formed. Now the question is, whether this is a weak acid than propanoic acid, is it a strong acid? Okay, so that is what you need to find out. Now we all know that chlorine exert minus I effect. Minus I effect means electron withdrawing inductive effect. My electron withdrawing inductive effect. If this group is withdrawing electron, the electron what is present between O and H will be more shifted towards oxygen. Polarity of the OH bond is more. If this is shifted more, then H plus can be easily lost. H plus can be easily removed. Therefore, minus I effect we all know that increases acidity. Minus I effect. Therefore, this is a stronger acid than propanoic acid. Option A. So it need not be the same question but related into I effect, E effect, R effect, the questions are asked. One more important area, student, from where you see a question. Now look here, resonance effect. Resonance effect is not observed in. Okay, so there are, you have seen several times questions asked on these effects, especially the resonance effect. Now, if you see the first one, I have clearly told you in my, YouTube session, previous classes, when I explained the resonance effect. In order to have a resonance effect, there should be double bond, single bond, double bond, or the pi electron should be in conjugation. There should be a conjugation, student. Okay. Now look here. This can shift here. This will shift here. So you have the resonance structure. You know that the resonance structure. CH2 single bond. CH2 single bond. CH double bond CH CH2 minus. This is minus, this is plus, isn't it? Other possibilities, this 5 electron coming here and coming this one. So resonance is observed. Look at this one. This pi electron can shift like this. This pi electron will be shifted. That means you have CH2, CH, double bond C and double bond N minus. So this is also, resonance effect. If you see chlorine is having, 7 electrons, out of which 1 is involved in bonding. That means there are 3 lone pair. So lone pair can be given. This pi electron is shifted. So you have a resonance structure CH2 minus, CH double bond Cl plus. Correct? So in this case, student, the lone pair and the pi bond are in conjugation. Okay? Now if you see here, you can see single bond, single bond. You cannot see under such case the, a conjugation. I mean the conjugation is not seen, resonance is not seen. See, if nitrogen has a lone pair also, if it is given, this bond cannot be shifted because there is only one bond here. That means this compound does not show resonance effect. Answer will be option D, student. Okay. Sometimes which orbital is not possible? Which orbital will be filled first? Which orbital will be closest to the nucleus? So, related to the orbitals, the question can be framed and asked. Now, this is a simple question. Sometimes when a simple question is asked, you will think much. But then students, remember, this is one simple question, the orbital near to the nucleus. Now, how do we find out orbital near to the nucleus? So it's very clearly evident that it is 4s. Otherwise, you can find out by n plus L rule. Whichever orbital has least energy, that orbital will be closest to the nucleus. Here it is 4 plus 0, n plus L. Here it is 7 plus sp, so 1. Here it is 5 plus spd, that means 2. L value is 2. Here it is 4 plus spdf, that means 3. So the least n plus L value is for 4s, so it is close to the nucleus. Now when you see chemical bonding, one more important area from where the questions have been repeatedly asked is hydrogen bonding. And one of the question is the intramolecular hydrogen bonding is present in. Students, when we say intramolecular, it is within the molecule. Okay? Within the molecule. When I say intermolecular, it is in between the molecule. Suppose if I take phenol, if you take the case of phenol, students, you will see intermolecular hydrogen bonding in between. If you see paracresol, option D, you see intermolecular hydrogen bonding. If you see para-nitrophenol, then also you will see intermolecular hydrogen bonding, not inter, in between the molecule. If you take the case of orthonitrophenol, okay, if you take the case of orthonitrophenol, now you have an oxygen atom and you have a hydrogen atom. So here you can expect a hydrogen bonding. This is within the molecule, inside the molecule. That means it is intramolecular hydrogen bonding. Option B will be the right answer. One more important area from where the question is asked is basicity and acidity. Which is strongly acidic, which is strongly basic. Now there are 4 options given. More basic compound is asked. You can see diphenylamine. You see diphenylamine. One option. Another option is triphenylamine. Triphenylamine. And the other one is para-nitroaniline. Para-nitroaniline. Then you have benzylamine. Benzylamine. Substance is said to be basic when it donates a lone pair of electron. This nitrogen is basic, this nitrogen is basic, this nitrogen is basic, this is also basic. Which is more basic? This lone pair of electron is given to the benzene ring involved in resonance. This lone pair is also can be given to the benzene ring involved in resonance. This lone pair, if you take, this lone pair also given to the benzene ring involved in resonance. So in these 3 cases, nitrogen possessing lone pair is directly attached to the benzene ring. And the lone pair is given to the benzene ring. It is involved in resonance. So they are not readily available for donation. readily available, availability is not there. Whereas student, in case of benzyl amine, the lone pair of electron is on nitrogen, which is not directly attached. It is not involved in resonance. That means freely available. Donation becomes easy. Therefore, this is strongly basic in nature. One more question, acidic character and the basic character, which is asked student. Okay. Now, based on SN1, SN2 reactions mechanism, the questions can be asked. Tertiary alkyl halide is practically inert to substitution by SN2 mechanism. When I say tertiary alkyl halide, this is tertiary alkyl halide. There are three methyl group. There are three alkyl group. Because of these three groups, the incoming group will experience always steric hindrance. Because this itself is a large molecule, so that will experience a steric hindrance. Because of the steric hindrance, it cannot undergo SN2. Rather, it can undergo SN1 mechanism. Therefore, answer will be option D. Now, when you look at the question number 9, it is from solid chapter. Solid chapter, one of the area where the questions are seen, that is getting a formula by giving the arrangement of atoms. Here if you see, in FCC, A and B atoms are present. A atoms are at the corners, B atoms are at the face. One corner atom, okay? So in which A atoms are at the corners and B atoms are at the face. Okay, and one corner atom is missing, student. Okay, one corner atom is missing. What is the structure or simplest formula of the compound? You see, there are, when I say a cube, if I am saying that there are particles at the corner, I mean to say there are 8 corners. But it is said that one corner is missing. That means I have 7A particle. And its share is 1 by 8, isn't it? Based on this also the questions have been asked. What is the contribution of a particle which is at the corner of the cube? If a particle is at the corner of the cube, its share for that cell is only 1 by 8. Then you have in the face centered B particle. Now how many face centers are there? Faces are there for a cube. There are 6. So 6 B particle, whenever they are present, what is their contribution? It is half. So you have 7 by 8 A and you have 3B. In other words, you have 7A and 24B. Or you can say A7 and B24. Therefore, the answer is option D. So, option D will be the right answer. So, for the time being, I am going to stop my session here, student. So, whenever we get a chance, we will discuss some more questions, some more, concept which has been repeatedly touched in, CET exams. So till then, take care and bye-bye. But then in case if you have loved the session, do not forget to press the like button and also share and subscribe the videos. Okay. So my next session will be on 29th exactly at 2 o'clock.